This plan, we're going to finish the scheduling, mainly focus on the use the method, which is the CMT and the PERT. There will be assignments based on what we talk about today. Okay, so you notice that this week we don't have the worksheet in class because we're working on those examples, and so there's an assignment that's similar to what we're doing in the class that will be due next Thursday. Okay, so there will be, I'll post the first part of the assignment today, and there will be another assignment on Thursday that's based on Thursday's content. Okay, so just a very brief review. So last time we talked about scheduling in project management. Okay, and the major method or tool that people use in doing scheduling or identifying those key milestones, like we call them events. Okay, for example, there are activities and events in network. And there are two different methods. One is called the activity on arrow, which is shown here. The activity on arrow represents an activity which is the actual task you do. Okay, for example, designing a certain part or like prototyping. So those will be activities, and activities has durations. Those are represented by those numbers after those activities. So like 18 time units. For example, if a time unit is days, so that means this activity D takes 18 days to finish. Okay, and the events are the ones that does not have durations. Okay, they're just like a certain time. For example, here, this circle, those circles here all represent events, and this event here representing activity E and activity F, both finish. So this is kind of like a milestone here. Okay, and by using this the CMP or PERT method or this network, what we can do is trying to find out how long a certain project takes. Okay, and which is the critical path. Critical path means the activities on that path cannot be delayed, otherwise the entire project will be delayed. And also later we'll talk about when we control the project, say when the project progresses for a certain for a period, and we found, okay, we are late for we're late, and we want to find out, okay, whether we can shrink the activity time, because those activity time, for example, this activity H, it takes 8 days at a certain cost. Okay, but if we can add cost, for example, if we add more people to the activity, we can shrink the time it takes, but we'll just add cost. Whether it's profitable or, I mean, like make sense to shrink that activity time or not, or which ones should we shrink, that's when the project progresses, we'll control it. Okay, so today we'll finish this. So this is one example we talked about last Thursday. And we also talked about the use of dummy activities to represent certain predecessors relationships. For example, if in this case, if A is not a predecessor of F, but both B and C are, then we use dummy activity and dummy arrows to represent that correctly. Then we end it at this problem here. Okay, so we'll read the problem again. So widget is made by assembly 1 unit of subassembly 1 and 1 unit of subassembly 2. Before production begins on the subassemblies, raw materials must be purchased and the machinery must be modified. Before the subassemblies can be assembled into the final widget, subassembly 2 must be inspected. Okay, so that's a assembly project which contains several activities. And we're going to first list activities and identify their predecessors in the table so that we can draw the network later. Okay, so let's work on this together. I read this again. So there are 2 sub-assemblies, 1 and 2. Seems like these 2 are parallel. Okay, and before production begins on some assemblies, raw material must be purchased. So before that means the production, before the production, so the raw material, purchasing raw material and the machinery be modified. These 2 kind of like parallel, and they are predecessors of the production on the subassembly line. Okay, and before the subassembly line can be assembled into the final widget, subassembly 2 must be inspected. Okay, so we can look at this. We'll start. So after reading this, which one is the last activity? Or which one is the first activity? Let's find out which one is the first activity, or which ones are the first activities. Which ones are the first activities? Buy material, okay. Like the raw material must be purchased, right? So I'll name this as A, activity A. And machinery must be modified. So these are two kind of parallel ones, okay, A, B. What about the next one? It says before production begins on the sub-assembly line. So that means they are going to produce on those two sub-assembly lines, and we have two of them, okay? So we'll have the production on sub-assembly 1 and 2. So this will be C and D, production on 1 and 2. And then after you have a production, then it said before the assembly lines can be assembled, okay? Before you assemble them, you need to sub-assembly 2. Okay, so 1 does not need to be inspected, but the 2 need to be. So this is E. Let me see. Yeah, so we'll name this as E. And then F and will be assembly. So by assembling. So assembly, this one will be F. Okay, so then I'll show you the table here. So we'll say, okay, A and B are the first two activities, and they don't have any predecessors. Okay, and then we progress to C. Sorry, we go to C. The production begins C and D, so they do have A and B as the predecessors, and then they go to E. E will have predecessors as C and okay. Let me ask you, which one is E's predecessor? E is inspect sub-assembly 2. Which one? D. Yes, thank you. So yeah, you produce on the sub-assembly 2, right? Okay, so D is E's predecessor. And then F will be the last step. Okay, so we have task A, purchase material, B, modify machinery. C and D are produced on sub-assembly line 1 and 2. And the E will be tested or inspected. And they have their predecessors. And F is the last one, assemble sub-assembly line 1 and 2, and their predecessors is C and E. So this one is the produce one and the test one. Okay, and they have their time listed here. Now we're going to draw the network. Okay, we're going to draw the activity on arrow network. So remember when we draw it, what's the first step? We have a circle, and that represents the event of starting the project. Good. Okay. So we're going to let's draw it here. So I brought my. Okay. So we'll always start from a starting point, starting event. Sometimes we put a start. Can you see it? Okay. Sometimes we put like a node as 1, sometimes we just as a start. Okay. And then when we start, we look at which activities do not have predecessors from the table. So A and B do not have predecessors. So that will be the one that we draw. A and B. And we always put activity on it. And in this table, the time units that takes for each activity to complete are given. So we put them behind it. And then we go, the next one is C, and we see that the C has a predecessor, which is A, so that means it's after this one. And so we need to have a, for every activity on arrow, we need 2 nodes to connect it, okay? Or actually, the events, so this one will be 1, this is your node 2, node 3. And after node 2, we have C, which has A as its predecessor. So C is 8 days. Okay. And then D, which has a predecessor being B. So we'll go from here. D has 7 days. Okay. Then now, after we finish everyone, first we'll just connect them like this. And we identify whether we need to just use 1 node to represent both. So after we finish C and D, and then we look at E here, okay? We look at E here. E's predecessor is D. So that means we go after this one. So E's predecessor is D and it has 4 days. And the F's predecessor is C and E. So which means we're going to continue, okay? So E, we're here now. So we finished E. I'm going to go up a little bit, running out of space. Okay, so E has 4 days. So this is the end of my E. And then F has the predecessor being C and E. So what should I do now? Both C and E are F's predecessors. So both this one and this one are F's predecessors. What should I do? So probably connect these 2 together.
No, you need an F. You need an F node and then use.
What's that?
From C and E. You need another path.
Need another path to go from where?
From with C and E.
Okay, so here, both C and E are F's predecessor. So this event, this activity and this activity are both F's predecessor. Okay, so basically we can just put these one together and draw. Okay, so here, so I'm going to just connect this one all the way down. All the way down here and then F. Okay, F, 3 days. And F is the last one, right? We look at the, when the table gets very big, you look at the predecessor part. You look at the predecessor part and F is not in it. So anything, okay, A, B, C, D, E, only F is not there. That means F is the last activity. Okay, so that's the one that we're going to finish. So it goes to end. Or we can number them now. 1, 2, 3, 4, 5, 6. So that's a simple network. And then from this network, we're going to find the critical path. Okay. The critical path studies the activity relationships determining the precedence of others, and also we're going to develop. So we first develop the network like this, and then we put the activity time on it, and then we'll find out, okay, how long does this project take? This is a simple example. We'll use this to illustrate how to calculate. Then we'll look at a more complex one. Okay. We perform a forward pass to establish the earliest start and earliest finish time for each activity. Okay, because some of the activities, like this one, F cannot start until C and E both finish. So the earliest start time for F is the earliest finish time for those 2 activities. And then we'll go backward. So we go from the beginning of forward pass to establish the earliest start and earliest finish for all the activities to identify the earliest finish time for our entire project. And then we go backward because, as you probably can imagine, those two lines, like this path here and this path here, they are parallel. But the activity on the both paths, they take different time to finish. Maybe one of them is longer. Okay, like the total time from B to D to E, compared to the total time from A to C, they will be different. So that means some of the, for example, suppose activities on this path here takes longer. Okay, in total, they take longer to finish. Then that means these two don't have to finish. For example, this one does not have to finish within 8 days. It can have some slack time. You can finish it a little late without affecting this entire project. Okay, so we're trying to find out what's the latest start and latest finish time for each activity. And we'll compute the slack time to determine the critical path. Some terms, those are the terms that we'll put on our network. Okay, a TI, a single estimate of the mean activity duration. So those ones here, those values here, those are the TIs. And a capital T, earliest. This one is the earliest event occurrence time. So let me ask you a question. What's the event on this network? The arrows or the circles? The event. The circles. The circles are the events. Okay. All those arrows are activities. So for every circle, we're going to have a TE, the earliest event occurrence time. So meaning, for example, here, the earliest time that both C and E complete. Okay, that will be the event time for this node 5 there. And then also we'll have a TL, the latest event time, representing the latest time that C and E can both finish. We'll put it here too. And we'll have those 4. So these two goes to the event on the circles, okay? We'll put them here. And then these ones are activities. So those are the earliest activity start time, earliest activity finish time, latest allowable activity start time, and the latest allowable activity finish time. Those ones we're going to put them on the activities, meaning on the arrows here. And then we'll calculate the total activity slack. So that's how we calculate, how we put those terms or those values on our network. So on this network, we already have this. Okay, so like the K, the activity, here. So this one, those are the activities number and the time it takes for the activity finish. And then we will put the latest start time, latest finish time, earliest start time, earliest finish time for this activity on the arrow. And for the events that this activity connects, we'll put the earliest event time and the latest event time, the same for this one. And those IJs are the event numbers. Okay, so those are the event numbers, like the 1, 2, 3, 4 we put there. Okay, so that's a term that we're going to calculate. Okay. So the earliest, we'll do the forward path first. We'll go from here to end to find out the earliest time. So the earliest occurrence time of the initial event, this one, the starting time. Okay. So remember, we'll put it here. Maybe I should change the color. So we'll have every event will have the T early and the T late, and we'll have just the number there. And for all the activities, we'll have late start. This is early start, late finish, early start, early finish. So that's what we're going to do, okay? And now we're going to go forward. We'll look at the earliest node. So we start from the beginning here. The earliest start time for our events is just 0. We just count this as 0. That's the earliest starting time. Okay, and then the earliest node. So that's for node 0. This initial event is just like the start or node 0. Okay, and then the earliest node occurrence time is the largest of the earliest finish time of the activities merging to the node. For example, we'll take this one as example again. So if we calculate the earliest finish time here to be 14. Okay, so we put the earliest finish time here. The earliest finish time for this activity is 14, and this one say 20. Meaning we can finish earliest finish time for E is 20, and earliest finish time for C is 14. Then, because for this event to happen, both activities need to finish. So we're going to put the largest. So the earliest time is this value here. So that's what this is about. It's the maximum, because you can't finish. This event cannot start until both events, or in some cases, several events that merge into this node all finish. Make sense, right? Okay. So then that's the event's earliest finish time. Okay. And then the earliest, this F cannot start until this event finish. So this earliest finish, the earliest start time for this event is 20. Then that means F's earliest start time is 20. So this number will translate to here. Okay, so we'll just work on them. And each activity's earliest finish time, that's pretty easy now. Like this one. The earliest finish time is basically when you can start plus how long does it take to finish finish that activity. Then we add 2 here. 23. Okay, so we'll use this example to calculate it. Then we'll talk about going backwards. So we'll go forward first. Use this as the example again. Okay, we already calculated. We already have this network. You already have it on your on your notes. So we're going to divide those events first. Okay, so that's the event. That's 0. Event 0. And we said on all the events we're going to put the earliest start time, event start time and event finish time there. Here. Okay, so the event start time is 0. Because that's the starting event. Okay, then we'll go this way first. When we go this way, we'll put the earliest starting time. So this is early starting time. Yes. For A. Earliest starting time is 0 for A now. Okay? Then you put it under it here. Then it takes 6 time units to finish A. So the earliest finish time for A is 6. We put it under this arrow at the end. Okay? And then we go to this event. This is event 1. Because there's no other event, so no other activity merged to here. So the finish time of A is the event time of node 6. And this time got translated to here. So this time always equals to there. That's the earliest event time. And that also represents the earliest time that the C can start. And the C takes 8 days to finish. So C's earliest finish time is 14 days, or 14 time units. Okay, now we'll head here. We'll go to the other path. Event time is 0. Takes 9 days for B to finish. So B's earliest finish time is 9. And the same here. So this is node 2. Because there's no other event going to this node. So this event's starting time is just 9. And we put 9 here. So that means D's earliest start time is 9. Okay? And it takes 7 days for D to finish. So D's earliest finish time is 16. And then you go to this another event, event 3. 16. No other events merged to here. So event time is 16. and E's starting time is then 16. Takes 4 days for E to complete. So the earliest finish time for E is 20. Now we're at this event here. So that's number 4. So node 4, now we have 2 activities going to this event, going to this node. And the occurrence of this event cannot happen until both of them finish. So we take the maximum to put it here. That's 20. Okay, so 20 becomes F's start time. And it takes 23 days. It takes 3 days to finish. So then, and that's the end. That's the end of the event. The event occurrence time is 23. Okay, so this is going forward. Going forward, we calculate the events occurring time, early occurring time, and all the activities early start, early finish time. Okay, any questions so far? Pretty easy. Okay, now we'll go to going backwards. Okay, going backwards, we're going to find out the latest allowable current time of a single terminal event. Okay, so so the terminal events represent the end event, or like in this case, number 6. Number 6. Okay, and that is just they are the same. It's the earliest event time, late event time. They are the same. And then we go backwards. So we finish this one, we go backwards. We look at the latest allowable finish time for an activity is its successor node's latest occurrence time for the successor node. And you subtract the time it takes to do the activity. And then you go backwards. Okay. And the latest allowable node occurrence time is the smallest of the latest allowable time. So this is the part different. So when you calculate an event, let me see, we don't have any example here. But when you have more than one activity, is going like in this case. For example, if there are okay, let's just use the example, or we'll use this example to illustrate it. So this node is the terminal node. So the latest event time is the same. Then we go backwards. So the latest finish time is 23. It's the same, okay? And it takes 3 days to finish. So it's just the 20 here. So for F, you can see that the earliest finish, latest finish, earliest start, latest start is the same. And when you go backward, this number here becomes this 20 here. Okay, and then that means again the latest finish time is the same. So when you come to here, you can see that the latest finish time, it's this value here. Okay, it's 20, and your event takes 8 days to finish. So the latest start time for this C is 12. Okay, and then here we only have one event, so it's the 12 here. And we can keep going. So the 12 is the latest finish time. You read from here and take 6 days. Okay, so that means for your activity A, you can actually just start on the 6th time unit. We'll just use days now. Okay, so you can start at the 6th day. You won't delay the activity. So now here, this one, 20 is the latest start time, and takes 4 days, so 16. So 16 becomes here, and 16 becomes here. 16 takes 7 days, so 9, and 9 here, 9 here. This 0 is that 0 was for the, move those a little bit. So that's for this event. Okay, so 9, 0. Okay, so now let me ask you, the latest start time is 6. on this activity A, and the latest start time is 0 here. What number do you put it there? This represents the start of the project. 0 or 6? 0. Okay, why? If you start at the 6, then this one will be delayed, right? Okay, so that's what it says earlier. It's like you take the smallest. Okay, so that's the 0 here. Okay, so now we have the network complete, and we're going to identify which ones are which path is the critical path. We'll basically look at which. So we can look at just on the event, or you can look at the slack. So if on that path there's no slack, meaning the earliest start and the earliest finish they are the same, then that means it's the critical path. So the node active path that illustrates no slack, which means earliest start equals earliest finish, or earliest finish equals for each activity on that critical path, then that's the critical path. So in this case, it's this one. Okay, so that's the critical path. And those are the activities that you cannot delay. If you delay them, then the entire project will be delayed. But like for these ones, so what's the slack here? The slack, you have a 6. Okay, for activity A, you have a 6 slack. And this one here too. But can we delay both for 6 days? No, okay, just one of them. Or like the entire slack is 6. Okay. So that's how we did. And we'll find out that's the critical path. Okay, so now we'll do another example. We'll do this quickly. To draw this network for the following action plan. Okay, I'll ask you guys to create the network first, yourself. Okay, so the network looks like this. And don't forget the ending node, okay? So always have this ending node here to connect all your last activities. In this case, H, I, and G, they all connect to here. We start from the ABCs. They don't have any predecessors, so we start from a starting node. So we create this starting node, and we have ABCs coming out. Okay, and then we look at, okay, A is the predecessor of D and E, so that means we'll have D and E coming out. And B is the predecessor of F, so we'll have F. And C is the predecessor of G. So we'll have a G also coming out there. Then D is predecessor of H. D. There's a H there. EF is the predecessor of I. EF. So we'll connect them together. There's this I here. So H, I, G, these are the last ones, so we'll just connect them all together to the ending node. So that's it. And then you start to work on the first row, first the node. Or I'll start with 1. 1, 2, 3, 4, 5, 6, 7. And the beginning node always starts from 0, and you do, okay, 0 here, 8, 0, 20. I'll move it a little bit to here. And the 0, 33, you go forward. And this 8 becomes to here, this 20 comes here, this 33 come here. So, and you keep going forward. So going forward, 8 8 becomes here and also here. And 8 plus 18, you got the 26 here. And this 28. This 20 comes here. 29. This 33 comes here. 43. Okay. And then when you go to this event, there's only one activity going into it, so 26. For this activity here, you have two activity going in. You take the largest. We're talking about the earliest finish. So that's 29. So it's this one here. And this one I have to wait. One need to wait for here. So this is 26. 26 becomes the earliest start time. And 8, 34. So 26 plus 8, 34. 29 here. 29 plus 4, 33. So you choose 34, 33, and 43. So 43 becomes the event for ending because that's the largest. And this is the terminal node now. Okay. And terminal node, so your event time, early finish and early start, it's the same. And then you go backward. So the latest finish time becomes 34 or 43 here, and 43 subtract 8, you got 35. And for this event, it's also 43. 43 subtract 4, 39. 43, 43. Okay, and 43, 33 here. And you keep going. So this 29. Oh, sorry, 39. 39 becomes here because that's the late finish time. Okay, and this late finish is 35. 30. So this is 35 comes here. 35 minus 18, 17. 17 comes to here. And this is 39 sub 20, 19. You have two events. Oh, sorry. Actually, I was wrong putting that there. Okay, so you have two events, two activities going in. The latest finish you need to take which one? This is 17. Yeah, you take the smallest. So that one should be 17 here. Okay. Yeah, and 29, 29, 20, 20. And this 17 comes to here. 17 subtract 8, 11. And this is 20, 0. And going here, 33, 33, 0. Did you get the same? The same. Okay, so which one is your critical path? So you look at the ones that has all the events. So this one has 0 slack, 0 slack. What about this one? These two have 0 slack, but this one does not, right? So that's not the critical path. Okay, so it's this one. So this one and this one has slack, slack, slack. So that's the critical path. So you go forward like this and then backward in this way. And that's the critical path. It's this one here. Okay? So that's for today.